Hi everyone and welcome to the question and presentation, Did God make a fake universe? And you might think it's a bit of an odd question, but there are a very large percentage of people in our world and in America today that actually believe that he did to some degree. So, first question is, this is the farthest object you can see with the naked eye. And there was a big debate back in the 1920s. We didn't know what this object was. I'll give you a second. You might squint at the picture. Well, that would be the Andromeda galaxy. It's located 2.5 million light years away. That's actually the closest galaxy to our Milky Way galaxy. And we know and estimate now that there are over 2 trillion other galaxies. And the other fact about this galaxy is that we're seeing it as it was 2.5 million years ago. Because the speed of light is constant, and if it's 2.5 million light years and light travels 1 light year per year, then that means that whenever we look out in space, we're seeing things as they were in the past, including the Andromeda galaxy as it was 2.5 million 2.5 million years ago. So, obviously, a nice question, fair question to ask. If creation occurred just 6,000 years ago, is this fake? And how did the light get here in just 6,000 years? And then, not only how did the light get here, but what about all the information that's contained in the light about different astrophysical processes? We know what elements make up various stars or galaxies. We can measure them with exquisite precision. We can see various astrophysical processes occurring in real time, and our universe has a very, very long history that we see very plainly. But first, I just wanted to touch upon some of the ideas. This is obviously a well-known problem in the young Earth community. And here are 7 of the kind of general ideas that folks have had. And I will go through each of them just a tiny bit, some of them in not very much detail. But basically, you question the distances. And in that one, you basically say, hey, well, all that stuff, it's not really 2.5 million light years away. The Andromeda galaxy is much, much, much closer, along with the other 2 trillion galaxies. And that just doesn't work. You can't squeeze the entire universe into a 6,000-year shell around us, 6,000 light-year shell around us. It doesn't make any sense. And we know very, very well using different methods like parallax or looking at variable stars or type 1a supernova or 2a supernova. Or is it 1A? I have to look it up. Or Hubble's law, for example. You can calibrate each of these very, very well out to billions of light years. So certainly the distances are legitimate. Here's one that's been presented in many creationism seminars, and that's that the speed of light has been decaying. So this graph starts in about 1870 up to about 100 years later than that. And you see that as we measure it, it seems that the speed of light has been decreasing. But one thing you'll notice, and please, whenever you're looking at these types of graphs, look at the error bars. They were huge back in the late 1800s and early 1900s. But as time went on, it's not that the speed of light was actually changing. It's that our ability to get it, to measure it, just got better. So it'd be very misleading for someone to present this graph today, and you would have no excuse for actually doing such. But it turns out that actually can still happen. So on the right, this was actually put together by Andrew Snelling, a geologist with Answers in Genesis. And he was doing the same type of thing that other creationists have done with the speed of light decay in a dishonest way. So he put up the measured half-life of a particular element. It's rubidium, I think strontium, and that radiometric decay process, and it has a half-life of 48 billion years. And you see the same type of thing, really big error bars early on, and he actually presents this graph to try and demonstrate that radiometric decay has changed and is not as reliable as we would like it to be. But you see, that is completely false, and his graph even proves the opposite, because look, the error bars are extremely small. And I'm putting this up here because we're going to touch a little bit on radiometric decay at the end, but we can measure very, very precisely the radiometric decay of any element, and including in stars. So another idea that has been put out there is light's been created on its way. That's basically that, oh, there's this stuff that's really, really far away, and then God just simply put the light there. So here's an example. Here's a picture. So if you focus on the picture for a moment, there is a big bright spot in the middle of that diagram and a telescope on the left. So you can imagine the telescope is taking a picture of that. And what it's taking a picture of, it's looking at the foreground galaxy, the big bright spot, and then behind the foreground galaxy, there's a supernova eruption in some kind of background galaxy. So from the perspective of the telescope, you see this little ring, and that's basically called gravitational lensing. That was something that Einstein predicted we should find in his 1915 formulation of general relativity, and it just so happens that we find that all over the place. But the problem is that many of these gravitationally lensed galaxies, supernova, etc., are billions of light years away. So the light hasn't had enough time to travel us if the universe is only 6,000 years old. So basically what that means is the light had to have been sent from right in front of the telescope and sent with fake information about gravitational lensing. So that starts to become a bit more of a problem. It's not just that did God or some kind of creator send the light from really, really close, faking an event that's out there, but also put certain physics in that event as well. That humans would just so happen to predict via some equations and then start measuring them in the 20th century. So another one could be accelerated by a miracle. God can do anything. It's not testable, of course. And if you change the speed of light, well, because of, well, the famous equation, E equals mc squared, that's the rest mass of a particle. If you change the speed of light, accelerated it by a factor of 13 billion, you would have changed the energy in space by a factor of 13 billion squared, or 190 quintillion. And that would, yeah, kind of, well, destroy the universe. So it's like, yeah, God accelerated the speed of light and hid all of the evidence of him actually doing that. So maybe that could be true. Or clocks are faster out there, and that would really not work. You can pause. I'm not going to focus on the slide. Just go ahead and pause it and look at it. Basically, if this was actually true, the Earth would be getting destroyed by radiation billions of times every second. And in this one, that certainly is not true because we can measure in real time different processes that, out in space that match timescales here on Earth. So we can actually measure transitions in elements in distant galaxies and measure them to be the same as they are on Earth. And I'll show you an actual paper of that later on. Another one's a technical trick came up with Jason Lisle. This was a big thing that he was working on, and I appreciate the young Earth creationist Todd Wood, who noted, that's in point 1b there. Science deals with the world of real things, not just logical possibilities. It just isn't science, speaking of Jason Lisle's idea. As he seems to freely admit, anisotropic synchrony convention is all about logical possibility, but it doesn't actually help us understand or explain galaxies or pulsars or redshifts or cosmic microwave background radiation. So basically the trick is that light travels instantly or infinitely fast towards us, but it travels at half the speed of light the other way, so that just whenever we measure it on average, it still averages out to be this constant speed of light. So it's a technical trick that actually can't be tested and therefore is pseudoscience, but it also would produce measurable gravitational waves if light was traveling infinitely fast in one direction, but we also, of course, don't measure those. So beyond all of this, I hinted at this a little bit, and we're going to look at some of these in more detail, but it's not only as if light had to have been somehow accelerated or just quickened, but there's a very, very long history that our universe has gone through from different astrophysical processes. So galaxies merging, new stars being born, stars dying, relativistic jets, gravitational waves, galactic snacks. So I'm going to go in some of these in more detail. How about having elements actually produced? Because we can measure certain elements appearing and being produced in certain astrophysical processes. Or with Big Bang nucleosynthesis, that's an amazingly accurate prediction that describes very, very well why we see that our universe is made up of about 23% helium by mass. And there's no real other explanation other than that one. So perhaps I'll do a video on that at some other time. It's really interesting. But first, here's some merging galaxies. This is a process where these would had to have been created extremely close to each other, just so that they would just merge and collapse. Now, this would be, of course, expected over time in any galaxy because gravity is an attractive force, but this is a process that takes quite a long time. For example, the Andromeda galaxy, that's 2.5 million light years away, which is really close in terms of the universe, it's going to take us some 3 billion years to collide with our closest galaxy. So here's stellar nurseries. This is a process that takes a long time because stars die. They basically shoot off their gas or contents in some kind of eruption, and then that gas collapses and produces new and young stars, and we see stars being born all the time in our universe. And so we also see stars dying, as I mentioned, and certain types of stars would take much longer to collapse than others, and we can, of course, model that very well with physics that we can test here on Earth, and it's a very violent and bright process. Another thing is relativistic jets, and so here's an artist illustration on the left, but basically what you have happening is you have a black hole in the center of some kind of galaxy. Most galaxies have a supermassive black hole in the center, including our own. And basically that matter is being pulled towards that as this black hole is rotating, and it heats up matter and ends up shooting matter out the top and the bottom in the form of a relativistic jet. And here's an actual X-ray image or a radio image or optical image of relativistic jets. The only deal is that these relativistic jets are sometimes millions of light years long. So basically, light has been shooting off at the bottom of a rotating black hole for millions of years, or it was just put there in a pretend way. So, also gravitational waves, that's of course a big one. We recently measured gravitational waves that contain information about various events, and there was a neat one that we had measured recently as well, which had to do with two merging neutron stars. So we actually measured the gravitational waves from that event and the actual electromagnetic radiation that was coming, and it just so happened that that event contained the exact elements that we predicted beforehand such events should create. But it's all fake, I guess. And so there's also a gravitational wave problem, not just a light problem. And then galactic snacks. Here's another thing. As I mentioned before, gravity is an attractive force. And sometimes galaxies are moving towards each other. Sometimes they're happily rotating around some external object. And so here is the local galactic group. The two bigger spots in this group are the Milky Way galaxy and the Andromeda galaxy. The Milky Way is in red there. And you see there's a number of little dwarf galaxies around the Milky Way galaxy. And over time, the Milky Way galaxy consumes them. Basically, they get pulled towards the Milky Way galaxy, and we eat them. So here's kind of our galactic plane there. There's a little dot representing where our sun would be. And it just so happens that we see streams of these previously consumed dwarf galaxies traveling through our universe. And you can model that. We can measure the location of such very precisely. And you see that there are galactic snacks that we've consumed 250 million years ago, 500 million years, 750 million years ago. So basically, not only are all of these astrophysical processes that we looked at before, and there's many more, but there's also a fake trail of a previous galactic snack that was just put there. And here's some modeling here. This is a GIF, but it might not come up. But you can go ahead and look up the particular research group there and see. Here's some modeling of 3 dwarf galaxies that would be disrupted and what they would look like over a 4 billion year process. So ultimately, what can we conclude from all of that? Well, there's certainly no solutions to the distant starlight problem, and now there's a distant gravitational wave problem, and the cosmos has a long history of events that must be fake or be made to look like they occurred. And so there are some of the processes that we talked about, and ... and there's a lot of history that gives this scientific age of 13.8 billion years. So what do you do with that? Well, there's one last trick up the sleeve of various folks, and that is changing the laws of nature. Maybe the laws were just different in the past. So it would be wrong for us to infer that the 2 merging neutron stars with the elements that we predicted should have we're actually real, and that we're actually there should be different chemistry going on in the past. And so that actually leads us into a general principle of science, which is uniformitarianism. And all that means is that the laws or processes of the present are keys to understanding the past. And that doesn't mean that everything changes really slowly, as some mistakenly teach. The definition's been updated in the past 50 years. So certainly you don't want to argue with the straw man version of what this principle actually represents, as many, many people do, unfortunately. But it's a fair question to ask. Have the laws of nature ever changed? Because, I mean, if you're a cosmologist measuring this, or if you're a geologist trying to measure the radiometric decay, it would be good to check that if you could. So, at very least, the first way to check it is just simply through Noether's theorem. That links the conservation of energy, which we've never seen broken, and you can make amazing predictions, even with virtual particles out of that, and the half-life of exotic particles in particle physics. And her theorem links the conservation of energy with what's called the time invariance of the laws of physics. So basically what that means is that if energy is conserved, then the laws of physics are constant. And vice versa, if the laws of physics are constant, then energy is conserved. And so that's one way to actually check it, to check the conservation of energy. Another way is to actually measure it. So you can make measurements of that. So here's one on the left. This is paper 2012 measuring the proton to electron mass ratio from alcohol molecular transitions in the early universe. And so this is looking at a galaxy that was 7 billion light years away, and they actually found that no, there was virtually no change, or the change was less than 1 part in 10 million. At least from what they were able to measure. If they had more accurate measurements, then they'd probably be able to constrain it much, much more. And so there's no reason why necessarily that such things had to have been constant, but we can measure the chemistry of events that occurred billions of years ago and find that they actually exactly match the chemistry of things that we measure here today on Earth. So, and then here's another one looking at the gravitational constant that found that perhaps their constraint was that the gravitational constant had changed at most by 0.1 parts per billion per year over the past 9 billion years. So virtually not at all. And again, with perhaps more accurate measurements, we could constrain it even farther. So that's the thing with physics and, well, science in general. I mean, if you have some kind of assumption, like the laws of nature have been constant, you would want some way to check that. Some way to possibly check whether or not what your assumptions are true, because it really, really would bother, and you have to take it with a grain of salt if you can't check your assumptions. And so here is another one, the fine structure constant. This one's actually really cool because there's here's a theoretical prediction that predicts how the fine structure constant should vary compared to what we measure based upon the expansion of the universe. So that's really cool, but they found that it varied by about 1 part in a billionth per second. Which is just absolutely crazy that you can measure that, of course. But that's not changing at all. So that's telling us that virtually, well, the laws of physics have not changed. And you could also measure it on shorter time scales. For example, some try to cast doubt on radiometric decay by saying, oh, the sun does stuff, changes the decay rate. Well, turns out you can check that, you can test that. And this paper just demonstrates that, no, there were no changes due to solar neutrinos or any effect by the 11.1 year solar cycle on the decay rate. So you can go and you can check those things and cross-check them against other physics that's based upon completely different processes. But one I'd like to touch upon just real briefly is the rate project, because this is probably one of the most substantial projects ever undertaken by the young Earth creationist community, where they do suggest that the laws of physics were changed. And, well, what did they find? Well, and what was the project? Well, basically, they sought to answer, if the Earth is 6,000 years old, why does radiometric dating consistently give results that are much older? And, of course, with this question was an admission that there is overwhelming evidence that hundreds of millions of years worth of nuclear decay has taken place since creation. So you can measure that here on Earth, you can measure it on the moon, you can measure it from meteorites that crash the Earth, you can measure it in stars that are far away from the Earth. But, of course they would say that doesn't mean the Earth is old, but just the nuclear decay rates were higher. In fact, they would have to be 1 billion times higher in the past. So what did they ultimately find? Well, not much. So no one's actually who's checked them, who's an expert in the field, has ever found their claims satisfactory. They've had a number of just simply technical flaws that could be removed by being more careful, and no one's been able to replicate their findings. And they haven't even released their data either. So basically it's just kind of like, oh yeah, this is still possible. We're not going to show you what we did, but it's possible. I assure you. That's not science. That's pseudoscience. And dare I say, it's somewhat deceptive and misleading. But even despite all that, let's say that, all right, that's fine. They found some stuff. The team itself noted the biggest problem of all, and that's that radioactive decay, it generates a lot of heat. So what would happen if you squeezed billions of years worth of radiogenic heating into just a fraction of a 6,000-year period? Well, you would heat the Earth to at least 22,000 degrees Celsius. So it's far hotter than the surface of the sun, and there's no explanation offered. Said, well, maybe there's some new laws of physics we don't know. And that's it. That's all that they found. They admitted the biggest problem themselves, and it was casually dismissed. And this project is touted as a success. Books, DVDs, conferences proclaiming that accelerated nuclear decay is a rock-solid fact, supported by, quote, overwhelming evidence. And it's not. It's a sham. It's a pseudoscientific sham that has no explanations or mechanisms behind it. And it's not really a casual thing to suggest that, oh yeah, the laws of physics were just different in the past. Like, just a factor of 1 billion, just so that it just so happens to work and squeeze into my 6,000-year time frame. All right, so ultimately, you need to have a very, very different universe than the one we see and we actually measure and can do calculations on, can make predictions on. Basically, this universe that is represented by the young Earth worldview is a fake one. We certainly have no evidence that the laws of nature have changed in many measurements and collaborating data that demonstrates that they never did change. And if they were, well, God just changed them and hid all the evidence of himself doing such. So there may be reasons why you might want to reject such a possibility that God would do such, that he's not a deceiver or a faker. And so here's the pillars of creation as they were 7,000 years ago, or about 1,000 years before the universe supposedly began. So I'll leave you with that, and there's a lot of beautiful things out there, but you just don't get to casually suggest things without any kind of evidence behind it. That's not science. So let me know if you have any other questions, and take care.